When a person reaches puberty, hypothalamo-pituitary-ovarian hormonal axis wakes up and starts operating. The hypothalamus releases GnRH in rhythmic spurts. GnRH stimulates the anterior pituitary gland to release FSH. FSH stops developing ovarian follicles from dying off prematurely. It promotes the growth and development of ovarian follicles. FSH targets specific cells in the ovary called granulosa cells. Acting on these cells leads to the production and secretion of two substances, estrogen and inhibin B. Inhibin B signals back to suppress or lower the release of FSH. As estrogen causes FSH levels to drop, follicles that have fewer receptors starve and die. Only the single dominant follicle survives because it has the maximum FSH receptors. High estrogen provides a positive trigger to spike luteinizing hormone levels. Estrogen builds up the lining of the uterus, endometrium. Because of this growth stimulation, you should never prescribe estrogen by itself to a patient who still has her uterus. Unchecked estrogen stimulation causes excessive thickening of the endometrium that is hyperplasia, which can progress to cancer. Granulosa cell tumor of ovary. Feminizing tumor. A tumor of these granulosa cells produces excess estrogen, classifying it as a feminizing tumor. Inhibin B serves as a tumor marker, used to detect or monitor this specific type of tumor. Let's understand the role of LH, luteinizing hormone. Estrogen has positive feedback on LH. It means high levels of estrogen stimulate the release and surge of luteinizing hormone. This surge is triggered by rising estrogen levels. Specifically, a threshold of around 200 picogram per milliliter of estrogen sustained for approximately 48 hours triggers the surge. The LH surge causes the primary oocyte to resume its first meiotic division, which is dependent on this hormonal trigger. This process culminates in ovulation, transitioning the oocyte from a primary to a secondary oocyte. The ruptured follicle transforms into the corpus luteum after ovulation. LH also targets and binds to receptors on theca cells in the ovarian follicle. Under LH stimulation, theca cells synthesize and produce androgens. These androgens travel to granulosa cells and adipose tissue, where the enzyme aromatase converts them into estrogens. LH also has direct or interacting roles involving granulosa cells within the ovarian dynamics. Let's clear the two-cell 2-gonadotropin theory. Inside the theca cells, cholesterol is converted via the CYP17 enzyme pathway into androgens like androstenedione and testosterone. LH binds to its receptor, utilizing cyclic AMP as a secondary messenger. Theca cells lack the aromatase enzyme, so they cannot make estrogen directly. Inside the granulosa cell, follicle-stimulating hormone acts on the granulosa cell via its receptor. Granulosa cells contain the aromatase enzyme to convert incoming androgens into estrogens, but lack CYP17. Androstenedione from theca cells is converted into estrone by aromatase. Testosterone from theca cells is converted into estradiol, the primary estrogen, by aromatase. Inside the adipose tissue, peripheral fat tissue can also convert circulating androstenedione into estrone using the aromatase enzyme. Thanks for watching. Subscribe for more updates.